This core is the Doe Creek member of the Cascapel Formation. This sits at the base of the Smoky Group and is right above the Dunvegan Formation. And like the Dunvegan, is Cenomanian in age. It's just a little bit younger. This core was logged in 2005 by Scott Reed, a master's student of George Pemberton, who did wonderful work on the Doe Creek member, and he observed lots of amazing bioturbation. And so I've chosen this core from his thesis because it shows really well some of the trace fossils that are very common in the Alberta subsurface, and that includes Ophiomorpha and Astrosoma, which is going to be the focus of this case in this core. Now, in general, the Doe Creek member, at least in this area where the core is taken from, goes from proximal offshore into lower shore face. So what we really have here is this vacillation back and forth between offshore and shore face, or maybe bay margin, bay line, or something like that, like lower energy shore face deposits. You can see the bioturbation is quite extensive in here. The bioturbation index is locally 5 or 6, and very rarely drops down to 2 or 3. And there's quite a range of trace fossils in here. Shown here are, for example, Planolides, Helminthopsis, Chondrites ophiuchus, Shobcylindricnus, Paleophycus, I would say Tychicnus, Ophiomorpha, and then Rhizocorellium, and Thalassinoides, and I don't know what that little dot is, but that's okay. Cylindricnus, perhaps, which we have down here. And the core itself, we've only laid out 3 boxes from the upper part here where it's very, very heavily bioturbated. I wanted to draw your attention to the core. You can see that it cleans upwards a little bit, and then it gets muddy again, and you have these large burrows in here. What do we see in general at this scale? Might be helpful to zoom in a little bit. You can see lower down where it's shaly, we actually have some tychicnus. That's what these sprida here are. These big circles are open burrows made by shrimp of Thalassinoides. You can see there's something here that has meniscae behind it. That might be Scalicia. You can have a little look. I'm going to label it on the core Scalicia, or we will label it on the core Scalicia, and that'll be our interpretation, I think. And then there's these things that look kind of spherical in cross section, not spherical, but circular to ellipsoidal, and these might be astrosoma. We're going to have a closer look at those, and you can see that this unit caps out with these mud-lined large diameter burrows that are Ophiomorpha. Like the Thalassinoides, this is a bit of a shrimp associated burrow, and it is commonly related to decapod crustaceans, which we'll look at briefly in a minute here. If you look through the core, there's a couple areas where I've labeled it as containing astrosoma. I wanted to emphasize astrosoma here because this is a good core to identify from. It's not the easiest trace fossil to identify in core. You're looking for patterns like this, where there's concentric reworking around what we call a causative burrow here. So you get these kind of what we call sprida or something like that. These are burrow linings here that are growing outwards from the shaft. There's another one here that's cut obliquely. These are probes made by an annelid, some type of worm, that radiate thus outwards from a central area like a star. Thus the name astrosoma. And so when we see them occur in clusters like 1 and 2 and maybe 3, we start to get the idea that this really is astrosoma. 1 in isolation is hard to assign to astrosoma, but a few at the same level really helps sell the interpretation. There's more astrosoma in this core. There's a little one down here, and I think it's associated with a vague one over here. And there's other trace fossils in here that you'll notice. Simply Planolides, those are just horizontal sand-filled tunnels in this case, and you might have little lined burrows like this that might be better referred to Paleophycus. There's parts of the astrosoma that are leaving sprida behind it. These are a type of tychicnus, and in a way we might consider this astrosoma to tychicnus to be what we call a composite trace fossil, which is kind of 2 trace fossils in one. Going to the top of the core boxes, the uppermost one, Here's a close-up view of the Ophiomorpha. Think of these as open branching tunnels and shafts that have a lining on them. And that lining is pressed into the sand by the animal that made the burrow, and it's to stabilize the burrow in the sediment. Okay, so these are all linings. It's an irregular lining, which is a dead giveaway for Ophiomorpha. This would be called Ophiomorpha nodosa, for example. But for now, just think of them as Ophiomorpha. You might be wondering, what are these little blebs in that left here and there? These are burrows that are partially preserved because they've been reburrowed after they were deposited. So what kind of animal makes these Ophiomorpha? Something like this fella here, that is a fella actually, it's a male. You can tell by the size of its claw. One big claw, one little claw is associated with males in this type of thalassinid shrimp, and it's known as Neotripea californiensis. That's a burrower that I've studied quite a bit on the West Coast, and they're very busy bioturbators. They can actually stir up a whole intertidal flat. And you will notice that in this core here, where we're looking at the core, each of these, by the way, is a shrimp mound. So it's digging at depth and it's bringing sediment up and it's putting it to the sediment water interface. So it's convecting all of this sand within the foreshore of this little beach here. And let's go back to the core here. And you can see, yeah, it's occurring kind of where it's sandiest and near the top of parasequences. Quite often we can associate Ophiomorpha with shoreface deposits like the lower shoreface, but you'll see it leak into the middle shoreface, and quite often it'll reappear again in the foreshore where it's a little sheltered from energy. And we certainly see it in intertidal flat deposits as well. So here you see kind of a record from probably proximal offshore on up to maybe low energy middle shore face or something like that. And ultimately, to put that into context here, this is, again, just to use the same paper as we used for the Rosellia and Phycosiphon Ichnofacies. McEachern and Ben had this diagram that Carrie drew rather painstakingly to show these distribution of fabrics associated with the Ichnofacies. And you can see we have Ophiomorpha. We have a lot of that. That's up the high. So we're kind of shifting from these parts that have astrosoma in them, which are generally considered deeper and part of the proximal Cruziana Ichnofacies, and might be occurring in the upper offshore or distal lower shore face. And we're going right up into the middle and lower shore face, middle and upper shore face where Ophiomorpha is. And if I had it my way at the foreshore, I would go back and drop in some Ophiomorpha here too, because that's quite possible too.